Now, beyond backups, there are other types of regular maintenance that you'll need to keep an eye on. One Redshift behavior that's going to be very important for whoever is maintaining the health of your system is to understand the concept and application of the vacuum process. Now, this will be pretty familiar to veterans of Postgres, but might be a new concept for people migrating from other SQL engines. To understand it, you simply have to know how Redshift performs deletes. When Redshift performs a delete, the resulting space is not automatically reclaimed. Further, since updates in Redshift are materialized physically as first a delete and then an insert, large amounts of either deletes or updates can result in a significant amount of storage that is technically empty but hasn't yet been reclaimed as free space to the Redshift cluster. Over time, these gaps, for lack of a better term, not only waste space, but cause the query processor a lot of extra work while it looks for relevant data through what could be mounds and mounds of deleted data. Now, while minor amounts of gaps will be normal, you don't want to let this build. The vacuum command instructs Redshift to reclaim this space. And as you might imagine, this can be a very I/O intensive process, so it should be managed carefully during times when table maintenance makes sense. There may be additional overhead in enforcing declared sort orders and other factors that can impact how heavy a process this is, including the frequency of previous vacuum operations and how much work there is to do to get everything back to the way it could and should be. So if the job of table maintenance and regular vacuuming falls to you, you'll want to get familiar with the ins and outs of this process. From a high level, it's important to know that you can run vacuum on your entire cluster, or you can run it against a single table, one at a time. In order to do this, you need to either be the table owner, in the case of a single table vacuum, or a super user, in the case of running the vacuum on the entire cluster. It's useful to note that anyone can call the vacuum command, and it won't give an error if they don't have the rights. It simply won't have the effect desired. An example of this would be a non-super user who is a table owner on a number of tables in the cluster, but not all of them. If that user were to run the command on the entire cluster, only those tables that the user owns would effectively be vacuumed. The rest would be skipped. So ensure the proper rights are in place in order to get an effective vacuum. Now, for detailed information, including the thresholds, the physical operations that occur, and guidance on determining how often a vacuum should be performed, go ahead and look up vacuum in the online Redshift documentation. It has a lot of useful tips and information in there. Now, one of the useful things that you'll find in the documentation is a reference to another system view that will give you insight into the progress of running vacuum commands, including things like time to complete, progress, and other very useful information.